Welcome to this deep dive. Today we're digging into something really key for anyone prepping for those senior software engineering interviews.
Yeah, API gateways and service meshes, definitely a hot topic.
Exactly. And honestly, they can get pretty confusing, right? It's a lot of hype, maybe some overlap.
For sure, it's easy to get tangled up in the buzzwords.
So our mission today is pretty clear. Break these down. What are they? Where do they actually fit in a microservices setup? How do they help? And maybe crucially, what are the common slip-ups?
Right. Aiming to give you that solid understanding, you need to talk confidently about system design, traffic patterns, all that good stuff in an interview.
Perfect. We want you walking away feeling like you can really explain this stuff, not just recite definitions.
Couldn't agree more. Demonstrating that deeper understanding, the why and when, that's what often separates candidates at the senior level.
Okay, let's dive in. Foundation first. Traffic flow. We hear north-south and east-west thrown around a lot. Can you unpack those for us? Especially thinking about how to explain this in an interview context.
Absolutely. So imagine your whole system could be in a data center, Kubernetes, whatever has sort of perimeter, a boundary.
Okay, like a virtual fence.
Yeah, exactly. North-south traffic is anything crossing that fence. Requests coming in from the outside world, say a user's browser or mobile app hitting your API, and the response is going back out. That's north-south.
Got it. In and out.
Right. Then you've got east-west traffic. That's all the communication happening inside the fence, your microservices talking to each other to get a job done.
Ah, okay. So service A needs data from service B. That call is east-west.
Precisely. It stays within your system boundary, one service calling another, maybe triggering another process. That's all internal, all east-west.
That's a really clear picture. External traffic crossing the border is north-south. Internal service chatter is east-west.
You got it.
And building on that picture, you can almost visualize where these components sit. The API gateway is like the border control for that north-south traffic.
Exactly. It's the front door managing who gets in and where they go.
And the service mesh is more like the internal road network, managing all that east-west communication between the services.
Perfectly put. The gateway manages external interactions. The mesh focuses on making the internal communication reliable and secure. They handle different flows.
Okay, let's zoom in on the API gateway then. For that senior interview, what's the core function they need to nail?
The absolute primary job of an API gateway is managing access from the outside world to your internal services. It's that single point of entry handling the north-south flow.
So it's like a gatekeeper or a receptionist for your entire system.
Yeah, or a traffic cop, maybe. It routes incoming requests, making sure they land at the right microservice, and it often handles security right at the edge.
And technically, how do they work? I hear they're basically fancy reverse proxies.
That's a good way to think about it. At their core, most API gateways are built on reverse proxy technology. They take an incoming request.
From the outside.
Right. They look at it, figure out, based on routing rules, which internal service needs to handle it, and then pass it along. Then the response comes back through the gateway to the original client.
But they do more than just routing, don't they? What are the common extra features?
Oh, yeah, definitely. You typically see things like API key management for authenticating callers.
Crucial for controlling access.
Absolutely. And detailed logging of requests and responses is vital for monitoring, debugging, auditing,
Makes sense.
and rate limiting. That's a big one for protecting your back-end services from getting overwhelmed, whether it's accidental or malicious.
Right, preventing abuse or just runaway clients.
Exactly. Some also offer developer portals to make it easier for people to discover and use your APIs.
Thinking about the history here with the whole API economy thing, it feels like some gateways got absolutely packed with features, maybe too many.
That's a really sharp observation. Yeah, the push towards the API economy definitely spurred a lot of feature development monetization, complex partner integrations, really advanced policy stuff.
Which might be overkill if you're just routing traffic from your own front-end app.
Precisely. If your main goal is managing traffic from, say, your web app to your backend services, a super heavy enterprise-grade gateway can add unnecessary complexity. Steeper learning curve, more operational burden, maybe even performance hits.
So it's about matching the tool to the actual problem you have.
Always. And sometimes, especially if you're already deep in Kubernetes, maybe a simpler Kubernetes ingress controller is enough for basic routing and TLS.
Right. Using the platform's native tools when possible.
Yeah, ingress controllers are often much leaner and integrate smoothly if your needs are straightforward external access within K8s. You could even use multiple gateways for different concerns, but then you're juggling more complexity again.
Okay, so for an interview candidate, what are the big red flags or anti-patterns to mention when talking about API gateways? Ways they get misused.
Good question. A major one is trying to do too much business logic in the gateway. Like call aggregation, making one gateway call, trigger 5 different backend service calls, and then stitching the results together.
Why is that bad? Seems convenient initially.
It seems convenient, but it quickly makes your gateway really smart and tightly coupled to specific client needs. It starts to know too much about the business process. The mantra should be dumb pipes, smart endpoints.
Right. Keep the infrastructure layer focused on infrastructure tasks.
Exactly. If you need that kind of aggregation or coordination, look at patterns like backend for frontends, BFFs, maybe GraphQL, or proper service orchestration with things like sagas. Keep the gateway lean.
Okay, so avoid complex business logic. What else?
Another one is trying to do heavy protocol transformation, like taking an old SOAP service and trying to make it look perfectly RESTful just by putting the gateway in front.
Why doesn't that work well?
Well, REST isn't just about JSON over HTTP, right? It's an architectural style. It's about resources, statelessness, trying to paper over a fundamentally different backend style at the gateway layer often leads to leaky abstractions and complexity just shifted to the wrong place. It's usually better to tackle that transformation closer to or within the service itself if needed.
Makes sense. And probably the biggest anti-pattern, using the gateway for internal service-to-service calls, that east-west traffic.
Oh, definitely. That's a huge one to avoid. Every internal call then has to take an extra network hop through the gateway.
Adding latency.
Exactly. Adding latency, adding load on the gateway itself, which is typically optimized for north-south patterns, not the potentially high volume of east-west traffic. It just adds unnecessary overhead.
So if the gateway isn't the right tool for that internal communication, that brings us neatly to service meshes.
Perfect transition, yes.
So what's the core job of a service mesh then, if the gateway handles the external stuff?
The service mesh is all about managing the communication between your microservices, that east-west traffic. Its goal is to take common operational concerns, things every service needs when talking to another service, and handle them consistently at the infrastructure level.
Like what sort of concerns?
Things like securing communication with mutual TLS, automatically adding correlation IDs for distributed tracing so you can follow a request across multiple services, service discovery so services can find each other dynamically, and sophisticated load balancing between service instances.
Okay, so instead of every single service team having to build, say, mTLS logic or retry logic into their code.
Exactly. Or relying on shared libraries, which can be a nightmare to maintain and update, especially if you have services in different languages.
The polyglot problem.
Right. The mesh handles these things outside the application code, usually via a sidecar proxy. This makes it language agnostic and ensures consistency across your whole fleet of services. Big win for larger orgs or polyglot environments.
Okay, the deployment model. Sidecars. That sounds important to understand for an interview. How does that actually work?
Yeah, it's fundamental. The idea is you deploy a lightweight proxy, the sidecar, right next to each instance of your microservice, often in the same pod in Kubernetes.
So they run together.
Exactly. And this sidecar intercepts all the network traffic coming into and going out of that specific service instance.
So the service itself just thinks it's talking locally.
Pretty much. When service A wants to call service B, the call goes from service A to its local sidecar proxy first. That proxy handles the mesh magic, maybe encrypts the traffic, pads tracing headers, figures out which instance of service B to talk to based on load balancing rules. Then it forwards the request to the sidecar proxy sitting next to service B. That proxy might decrypt it, check policies, and then finally deliver the request to the actual service B application code.
Wow, okay, so the proxies do all the heavy lifting for inter-service communication.
Yeah.
And how are these proxies managed? There must be something coordinating them.
Right, that's the other key part. The control plane. You have all these distributed data plane proxies, the sidecars, and then you have a centralized control plane.
And its job is?
Its job is to configure all the sidecars. It pushes down routing rules, security policies, collects telemetry data for observability, basically tells the sidecars how to behave.
So central brain, distributed muscle.
That's a great analogy, yeah.
Mm.
And you mentioned Kubernetes. The typical model there is one pod contains your application container and the sidecar proxy container. They share the same network namespace, making that interception straightforward.
I keep hearing about Envoy proxy in this context. Is that important to know about?
Definitely. Envoy is probably the most popular data plane proxy used in service meshes. It's high performance, written in C++F, very flexible.
What makes it popular?
Key things are its dynamic configuration via APIs, the XDS APIs, which the control plane uses. It supports modern protocols like HTTP2 and gRPC really well, and it has great built-in observability features. Big projects like Istio, Ambassador use Envoy under the hood.
Okay. Now, a potential pushback someone might get in an interview. Isn't putting all this logic, retries, timeouts, routing into the mesh just creating another smart pipe, like the old ESB anti-pattern we wanted to avoid?
That's a fair question, and it's important to address the distinction. The key difference is the type of logic. Service meshes handle generic operational concerns.
Not business logic.
Right. It's about network reliability and security timeouts, retries, circuit breaking, mTLS. It's not about understanding the business data or orchestrating business processes. And importantly, while the control plane manages it, you can usually configure these policies on a fine-grained per-service basis. So service A might need different retry settings than service B.
So it's configurable infrastructure logic, not embedded business rules.
Exactly. It keeps the application focused on its business domain, while the mesh handles the complexities of distributed systems communication reliably.
It sounds like the whole service mesh area has matured a lot recently. It used to feel quite unstable.
Oh, absolutely. The early days, maybe 5, 6 years ago, were definitely a bit Wild West. Lots of competing ideas, projects changing direction, Linkerd 1 versus Linkerd 2, Istio's complexity. It made adoption kind of tricky.
So what's the state now?
Much more stable. The core concepts are better understood. The main projects like Istio, Linkerd, Console Connect are more mature, and there's a healthier ecosystem. The initial hype has settled, and people are using them more pragmatically, understanding that evolution shows good context.
So when should a team consider a service mesh? It adds complexity, right?
It definitely adds an extra layer of infrastructure to manage, so it's not a day one requirement for every project.
Not for a two-service startup.
Probably not, no. But as you scale, especially when you have, say, dozens or hundreds of microservices, maybe multiple teams, different languages involved, that's when the benefits really start to shine.
The consistency, the observability.
Exactly. Taking that operational burden off individual teams, enforcing security policies consistently, getting unified visibility, it becomes very valuable, especially on a platform like Kubernetes where sidecar injection is relatively straightforward. You mentioned Monzo earlier. Their journey from Linkerd to a custom Envoy setup is a classic example of a scaling company grappling with and evolving their service mesh strategy.
Okay. One last check on service meshes.
Yeah.
Limitations.
Yeah.
Do they handle everything? What about things like Kafka or message queues?
That's a key limitation to be aware of. Service meshes primarily focus on synchronous request-response traffic, typically HTTP, gRPC. Communication via asynchronous message brokers like Kafka or RabbitMQ often bypasses the mesh proxies entirely.
So the mesh wouldn't automatically secure or observe Kafka messages between services.
Generally, no. The interaction model is different. While some meshes are exploring ways to integrate or provide visibility, it's not their core strength today. So you still need other mechanisms to secure and monitor that kind of asynchronous communication. It's not a silver bullet for all inter-service communication.
Okay, that's super helpful. So we have API gateways for north-south, service meshes for east-west. They seem distinct, but is there any overlap? How do they complement each other?
There can be some feature overlap, yeah. You know, a gateway might offer basic rate limiting, a mesh might too, but their primary focus, their reason for being, is different.
Gateway equaled edge security and external management.
Right. Managing who gets in, initial routing, maybe some transformation specific to external clients, protecting the perimeter.
Mesh, internal reliability, and observability.
Exactly. Making sure the internal service-to-service calls are secure, reliable, observable, load balanced properly. Managing the internal chaos, essentially.
So they really work best together in a mature microservices setup.
Absolutely. The gateway handles the request coming in, authenticates it, maybe does some initial validation, routes it to the first service. Once it's inside, the service mesh takes over, ensuring that request and subsequent internal requests it triggers flows reliably and securely between all the necessary internal services.
So reinforcing that for interview prep. Gateway is the bouncer and receptionist at the front door. Mesh is the internal comms system, ensuring everything runs smoothly inside the building.
Perfect analogy. Different roles, different problems they solve, but both crucial for a complex, distributed system. Understanding that division of labor is key.
Okay, let's try and wrap this up. Key takeaways. API gateways, your front door for external traffic. Control access, handle initial routing, security at the edge.
Yep, north-south traffic.
Service meshes, your internal communication fabric, making service-to-service calls reliable, secure, observable.
East-west traffic takes operational burden off the services themselves.
And understanding both, and crucially why you'd use them, the problems they solve, that's vital for those senior engineering interviews.
Absolutely. Don't just know what they are, know why they exist and when to apply them. Be ready to talk trade-offs. Why use a mesh here? Why use a gateway there? What happens if you misuse them?
Thinking about those anti-patterns we discussed.
Exactly. Articulating those trade-offs clearly shows real understanding.
And we definitely recommend folks dig into specific tools too, right? Look at Ambassador, Kong, Istio, Linkerd.
For sure, get a feel for their features, their configuration, maybe their pros and cons. Having some familiarity with actual implementations makes the conversation much more concrete.
Great advice. This whole area keeps evolving, so that continuous learning mindset is pretty important.
Couldn't agree more. The fundamentals we discussed, managing external access, managing internal communication complexity, those problems aren't going away. The tools might change, but the core challenges remain.
Well, this has been incredibly insightful. Hopefully this gives everyone listening a much clearer picture and boosts their confidence for those upcoming interviews.
Hope so too. It's complex, but breaking it down helps.
Thanks for joining us on this deep dive. We'll catch you on the next one.